Many students spend many hours, day in and day out, in study halls. Unfortunately, a lot of students are struggling with working effectively. Headaches, lack of concentration, dry eyes, and sore throat are all symptoms of suboptimal indoor environment, and it's something a lot of students experience every single day. We call our device StudyAir, and it's a device to help cope with these problems. The device is equipped with LED lights that will light green if it's a good study environment, or it will light red for a bad study environment.
Everyone, this room sucks so much. Let's go another place where the study air is much better.
A user can log in with a mobile phone and view measurements transferred from his or her device. You can also view the measurement history of the places you've been and make comparisons. The device being used is a Raspberry Pi along with a SenseHat attachment board for measuring temperature, humidity, and air pressure. The measurements are transferred over MQTT to a server. The measurements are then stored into a database. Right now, there are no active measurements in the database. Normally, the Pi will update its measurements every 3 minutes. However, it can also be forced to make updates. For example, by the push of a button. The Pi has made its measurements and it's successfully been stored in the database. The information that is sent from a Pi will be available to all users who subscribe to the device. All data is stored for future use, providing a history which can be analyzed over time. First, the server is initialized with Spring Boot. As long as the server is running, it will keep track of all the Pis and all the users that are connected to it. Right now, there's only one user connected to the server. If we want, we can create a new user. Let's make a user for one of our team members. As we can see, there are now 2 users stored in the database. You can also assign a user to the Pi. Every Pi has its own unique value, and this value is being used when the Pi is publishing messages to make identification easier. The database also supports login systems. The database has the capacity to keep track of an unlimited amount of users and Pis simultaneously, along with the measurement history. All parts of the system can run independently of each other on both different physical machines and networks. We are currently utilizing cloud platforms, having the broker set up in the cloud MQTT service and our server running on the Heroku platform while communicating with the MongoDB. This is what gives us the ability to simultaneously manage an unlimited amount of Pis and users while maintaining a robust and efficient system.